Hi, let's learn about electric field lines or electric line of force. It is defined as the path along which a unit positive charge would move if it is free to do so. Means if we set a positive charge free, the path along which the charge moved is called electric field lines or electric line of force. Electric field lines show the direction and strength of the electric field. They point away from the positive charges and toward negative charges that you can see in this figure. For the positive charge, electric field lines moved away from the charges, and for the negative charges, it is coming towards the negative charges. Or we can say that for positive charges, electric field lines goes to infinity, and for the negative charges, electric field lines comes from infinity. And this figure shows electric field lines between two equal and opposite charges. As you know, for the positive charges, electric field lines started, and for the negative charges, it ends here. So, from the positive charges, this electric field line started and it ends at negative charges. Here you can see all the electric field lines are formed between positive and negative charges. As these are unlike charges, the electrostatic force is attractive. And between two equal and like charges means here two positive charges are shown as like charges repel, electric field lines repelled each other. You can see from this figure. Let's see the properties of electric field lines. The first property is non-intersecting lines. Electric field lines never intersect each other. If they did, they would imply two directions for the electric field at that point, which is impossible. That you can understand from this figure. Here, electric field lines never intersected each other. The second property is perpendicular to surface. The field lines are perpendicular to the surface of the charge. Imagine them as arrows pointing outward from positive charges and inward towards negative charges. The field lines are perpendicular to the surface of the charge. The second is relative strength. The density of field lines around a point correspond to the strength of the electric field at that point. More lines near a point indicate stronger field. That we discussed earlier. The density of electric field lines indicate the field lines. The same point is given here. Relative strength. If the field lines are crowded together, it indicates the strength of the field. The field is more stronger. And if the field lines are far apart, it indicates weak electric field. Start and end points. Field lines start at positive charges and end at negative charges. For field lines to either start or end at infinity, a single charge must be used. Next property, uniform field. In a uniform electric field, the field lines are parallel and equally spaced. This occurs between two parallel plates with opposite charges. Next property is radial field. Around a point charge, electric field lines are radial, extending outward from the charge. They resemble the spokes of the field. That you can understand from this figure. Next property is closed loops. Electric field lines never form closed loops. If they did, it would imply a net charge enclosed within the loop, which violates Gauss law. Last property is equipotential surface. Electric field lines are always perpendicular to equipotential surface. These surfaces have the same electric potential available. Thank you.